Okay guys, in this lesson we are going to be studying 4 major reaction types. There is a review worksheet associated with this lesson, but no bookwork, and the aim that you'll need to copy down as the first thing that you write in the second page of your notes or the classwork today is the aim, what are the most common chemical reaction types? So the do now is right here. Copy it down. You don't need to solve it. We'll solve it in class tomorrow. And we'll start with the mini lesson right down here. Okay, so chemical changes are a result of chemical reactions, and all chemical reactions involve a change in substances and a change in energy. Neither matter nor energy is created or destroyed in a chemical reaction. However, it can be rearranged. There are so many chemical reactions that it's helpful to classify them into 4 general types. The synthesis reactions for me are either thought of as letters like this or with a picture. So in terms of letters, what you can see is that we have a hydrogen and an oxygen making a water. They are coming together from smaller parts to make a larger part. Or if you think of like an emaciated bird eating a worm and then it's like a very plump and happy bird, then that also, these two things have come together to make one thing. So that's also synthesis. So in a synthesis reaction, we have 2 reactants coming together to form one product, or something similar. Let's take a look at decomposition reactions. So in a decomposition reaction, we have a more complex substance that's breaking down into less complex substances. Like we have a water molecule which is breaking down into its components, hydrogen and oxygen. Or maybe we have a turtle egg which is hatching and breaking apart into just the egg shell and the turtle itself. So the products are actually, there are more products than there are reactants in this stage. Okay, let's do a single replacement example. In a single replacement reaction, a single element replaces another one in a compound. There are 2 reactants and 2 products. For example, if we were to use just some regular old zinc and combine it with hydrochloric acid, we would notice that we would get 2 new products. One of them would be zinc chloride, which is sort of like a white powder, but once it's dissolved, it's colorless. And we would also get hydrogen gas. So 2 reactants, 2 products. You can visualize it in terms of like an old-timey school dance, where you have one guy who doesn't have a partner right here, and then we have a dancing couple, but they can switch so that these 2 men can change places, and the man in the white shirt could be alone, whereas the man in the dark shirt could be dancing. So that's a single replacement because only one replacement was made, meaning this guy replaced this guy. There's your one replacement. So a part of one of the reactants has traded places and it's in a different place among the products. Okay, next page. So a double replacement reaction is sort of like a single replacement reaction, only there are 2 replacements that are happening. So we can do this in terms of elements. Like for instance, let's say we have some silver nitrate combining with sodium chloride, and let's say that the silver replaces the sodium to give us a silver chloride right here. But instead of the sodium and the nitrate just being separate, let's say that the sodium comes over and bonds to the nitrate. So in essence, while the silver replaced the sodium, likewise the sodium is replacing the silver. So there are 2 replacements when you do this reaction. And you have 2 reactants and 2 products, just like the single replacement reaction. You could think about this also in terms of diagrams or cartoons. So if we have these 2 dudes and we have these 2 hats, if they switch hats, then that's a double replacement. Okay, so we have a pair up and summary which are going to be right here. Please copy down these questions in condensed form, and we'll work on those in class tomorrow. So thank you for watching and learning about synthesis, decomposition, single replacement, and double replacement reactions.